All right, welcome back. I'm going to show you now what exactly is happening during melting and what exactly is happening during boiling or vaporization. I should note evaporation also happens, but evaporation can happen at any temperature, and vaporization and boiling always happens at a certain temperature, which I forgot to add. So I'm going to add that now. If we're dealing with water, vaporization and boiling is always going to happen at 100 degrees Celsius. Always going to happen at that point. So let's take a closer look at melting. So if we're looking at melting right here, remember that heat is still being added, energy is still being added, even though we're not rising in temperature. We're going to look at these two pictures, okay? This right here is going to be this. This is exactly at this point they are vibrating very fast. They're the fastest that they can vibrate and not break apart. When we get to the middle right here, at this point, we now have, and I'm going to draw a vessel like over here. We now have, let's say, two of them are still vibrating. They're still solids. And now we have two that have broken off and they've become a liquid. And you'll notice that I'm drawing these arrows the same as these, because at this point right here is where everything has melted. And we are now only liquid, and we are the same speed here and here. The particles move the same speed. So during this whole thing, from here to here, particles move at the same speed. And this is a hard concept, everyone, to understand. It is a hard concept because we have a lot of misconceptions. You think when it's melting, the temperature would rise, but the temperature does not rise because we have E phase energy happening right now. We have energy that's changing the arrangement of the particles. We are going from a solid to a liquid. It's changing the arrangement. It's changing the arrangement. So let's go up here now. And again, you can pause this and you can write down if you didn't get it all down. So E phase right here. I drew these also. So these right here are the same length as these. So again, at this point, we are only liquid. Okay, we are only liquid. And at this point, we're only liquid. And we are moving as fast as a liquid can move. We are moving as fast as a liquid can move and stay a liquid. In the middle here, right, in the middle, we are now going to be half and half because that's like the halfway point. So we still have particles that are moving fast, the same speed, but now we have some particles that have left, they have now turned into gas. So this is gas and this is liquid. Right here, liquid, solid. Just put it there. And at this point, these arrows, I tried to draw the same as here. So again, at this point, particles move at the same speed. They're moving at the same speed. So here we have all gas. So E phase, the most important thing to know is E phase is still energy being added, but that energy is going into changing the particles into a solid to a liquid and a liquid to a gas. And so there is no temperature rise. There is no rising of the temperature. Energy is still added this entire time, but there's no rising of the temperature. Now there's one more thing we have to go over. This is the heating curve. Okay, this is a heating curve. And of course, we're going from, we're melting and we're boiling. Okay, but there's also the cooling curve, which is going the opposite way. It's starting from a gas and it's working its way down. The cooling curve of water is going to look something like this. It's the exact opposite. Here we're going up. Here we're going down. Same thing at this first plateau. We have, instead of boiling or vaporization, we have condensing. It's still at 100 degrees Celsius. So at this point, we have condensing. And this is going from a gas to a liquid. Gas to a liquid, happening at 100 degrees. We have a gas right here. Here is where we have a liquid. And then down here is where we have the solid. And then at this point right here, condensing, going from a liquid to a solid is called freezing. And that happens also at 0 degrees Celsius. And just like on the heating curve, on the cooling curve, we also have, let me focus that a little bit there. On the heating curve, the cooling curve, we also have E thermal, where we have temperature rising. Temperature falling. E thermal, this time temperature is falling. And we have E phase, where we have freezing and condensing happens. So it's the same graph, and all of these are happening as well. It's just that we're going from a gas to a liquid and from liquid to a solid. So the pictures would just change, but the outline is the same. And instead of heat added over time, I made a typo here. This should be heat taken away over time. So energy is getting less. We are losing energy. We are losing energy as we go down. We are losing energy over time. So in this case, here, the E phase was used to break apart from a liquid to a gas, breaking apart. Here, they're using it to go back together again. Gas going down to a liquid, liquid going to a solid. The E phase is being used to pull those particles together. All of this should be in your notebook. 4 notes on the heating curve of water and the cooling curve of water. If you have any questions, please let your teachers know.